There are three different types of intersections: interior, on, and exterior. In this part 1 video, we are going to talk about just the interior and on. Part 2's video will talk about the exterior intersections of circles. Just for the basic definitions here, if we're talking about an intersection that occurs on the interior of the circle, we're talking about two lines that intersect somewhere inside of the circle. If we're talking about on intersections, then we're talking about some sort of a tangent line and then something else that's intersecting it at that point of intersection with the circle. If we're talking about exterior intersections, then it's some sort of lines that intersect on the exterior of the circle. Now, if we start talking about interior intersections, the rule of thumb tells us that the measure of the angle is half the sum of its intercepted arcs. If we look here, we see that we have these two lines that intersect inside of the circle. Our point of intersection would be where X is. So if we look at the intercepted arcs, we'd be looking at 120 degrees and 136 degrees. So if we find the average between those two, then we're going to be able to find the measure of angle X here. So X is going to be equal to half of the 120 degrees plus the 136 degrees. So in that case, we're looking at half of 256, which is going to be 128 degrees. And now that's going to be the measure of angle X, as well as obviously its vertical angle down here. If we look at our second example, it's the same idea, it's the same concept, but now if we're looking at the intercepted arcs, we technically only know one of them. We know this intercepted arc at 50, and we're being asked to find this intercepted arc named X down here. But we are given the interior angle measure. So if we keep that exact same idea true, then our interior angle is equal to half of the 50 plus the X, the intercepted arcs added together. So if I start solving, I'm going to multiply both sides by 2, and then I can go ahead and subtract 50 from both sides, and that's going to give X here a value of 110 degrees. And if we go to check this, the average of 110 and 50 is going to give us our 80 degrees. The next type of intersection is on intersections, and these intersections we can think about really as just inscribed angles. If you recall, for inscribed angles, those are angles that occur when the intersection is on the circle itself. This is the exact same idea. We have an intersection that's on the circle, so really we just need to find half of the arc measure to get our angle. So on this side here, our arc measure is 196 degrees, so half of 196. Half of 196 is going to give us, half of 196 is going to give us 98 degrees. So 98 degrees will be our angle down here. If we keep the exact same idea true and we look at the arc on the other side, so let's switch up the colors. Arc on this side is given to us at 164 degrees. So if we look for half of that amount, that one's going to give us 82 degrees. And this makes sense. This is a nice little check for us in this problem, because if we add these two values together, the 98 and the 82, they do sum up to 180 degrees, which is exactly the sum of a line. So that makes sense for us, so that checks out. If we look at our next example, again, same concept, just going to switch up the perspectives. Here we're being told that our angle measure is going to be 125 degrees. So our 125 degrees talks about this arc right here that we're labeling with an A. So if we take our 125, now we're going the opposite way, so we're going to have to multiply it by 2 to get 250 degrees as a measure of our arc for A. Now, how do we figure out B? So we have two options. If we look at the first option, we know that the sum of any arc measure within a circle has to be 360 degrees. So our other arc measure is where B is. So if we take 360, our sum of a circle, subtract out one arc, that's going to give us 110 degrees as our value for B. Now we can check that answer because we know that this angle over here at the intersection has to be half that value. So half of 110 is 55 degrees. And if we add those two together, 125 and 55 does come out to 180 degrees, which is our sum of a line. So that definitely does check out. Like I said, this is part 1.